Welcome back. Let's take a look now at the homestead design process. There are many different design processes that you may use and develop when designing your homestead. The one that we'll be looking at in depth begins with identifying a few key factors about our sites, articulating goals, and performing a thorough site analysis. As we begin to uncover the processes and functions of our site, the design for the site will emerge from our analysis. There are a few items that you'll need to obtain this week in order to complete the assignments. Please get a large drawing pad, 16 by 20 inches is recommended, an engineer's scale ruler. Be sure to get an engineer's scale and not the architect's scale. You'll also need a drawing compass and large pieces of tracing paper, about the same size as your drawing pad. You may also like to obtain a property map of your site, which is available at your town hall assessor's office. The first few things that you'll want to determine about your site are the solar aspect, your climate hardiness zone, and the watershed that your site is a part of. Solar aspect refers to which compass direction your site faces, north, south, east, or west. A south-facing site is often considered to be ideal because it will receive the most solar radiation. Your climate hardiness zone can be found on the USDA Plant Hardiness Zone Maps database. That's the U.S. Department of Agriculture Plant Hardiness Zone Maps. The hardiness zone determines what types of plants you can grow at your homestead. Studying your watershed and water sources close to your site will provide information and insight into meeting the needs for irrigation water. Let's take a look at how to use Google Maps to determine the solar aspect of your site. Type your site address into Google Maps. The top of your map will be labeled north. Look at the largest planting areas on your site and note which quadrant they lie in, either the north, south, east, or west. If a potential garden area is located in the eastern part of the site and slopes down to the east, it is said to have an easterly aspect. Sketch out the areas of your site and the aspect of each. Here's an example. In this design, the house is in the northwest corner of the site. You can see it as a brown rectangle. The garden in the lower half of the design faces southeast. You can see the compass directions in the upper right-hand corner. A garden in the southernmost part of the site will receive the most direct sunlight. Your hardiness zone is easy to determine by referencing the U.S. Department of Agriculture Plant Hardiness Zone Maps online. It's important to determine your USDA hardiness zone because it will guide the types of plants that you can grow in your climate. Plant hardiness zones are calculated based on the minimum average winter temperature. For example, a zone 6B would have an average minimum temperature of -5 degrees Fahrenheit to 0 degrees Fahrenheit. The next zone warmer is a 7A, with winter temperatures averaging between 0 degrees Fahrenheit and 5 degrees above zero. Massachusetts, for example, ranges from a zone 5 in the Berkshires in western Mass to a zone 7 in the coastal regions of the Cape. Please take a look at the following video on watersheds, which can be found under videos in Module 2. Also, look up the name of your local watershed and situate your site in relation to your watershed so you know what part of the watershed your site is in. What are the major rivers and streams near your site? Where does water go from your site after a rain? We'll be looking at these questions in detail as we move through this presentation. Now we're ready to begin step 1 of our design process. Last week we started our goals articulation with the emerging patterns assignment. This week we can refine our goals a little bit more by asking why you want the things that you want. Begin asking questions to clarify your intentions. How do you form connections to the things that sustain you? Here are a few things that you may want to include as you revisit your goals articulation. What types of foods and useful products would you like to have at your site? Are there any other essential needs that you want your site to meet, such as aesthetic, emotional, or spiritual needs. How does your garden relate to the larger context of your neighborhood and your local community? What's the amount of maintenance that your garden will require? And take a look at what your approximate budget will be for the garden. The site analysis and assessment is guided by the scale of permanence and a thorough analysis of existing conditions. In this stage, we don't design. We simply make observations and note our interpretations of what we observe. Your site analysis will begin with a base map. A base map is a map of all of the important site features drawn at an appropriate scale. One way to get an accurate base map is to visit your local assessor's office at your town hall building and ask them for a map of your property. Most towns also have online GIS mapping systems that will allow you to print the map from your computer. Once you obtain this map, trace the map on a fresh sheet of tracing paper and label where north is. Now you're ready to begin your site analysis. Making your own base map can be a very useful exercise and can illuminate site features that you may never have noticed before. Even if you are using an assessor's map, you will need to add major site features to the map. Use the guidelines on this slide to get you started. Step 1. Measure your property boundaries and record them in a notebook. Start with the property line along the street and then measure from the street to a corner of your house. Make a rough sketch of the property, measuring all the property lines as best you can. It's fine to approximate your property lines. Step 2. Measure the dimensions of your house, all of the exterior walls, and the distance of your house from all relevant property lines. Step 3. Put in the rest of your site features. Indicate where the gutters and downspouts are, where you would find hose spigots, wells, septic systems, etc. Once we have all of the basic measurements, it's time to begin drawing your map. Please be sure to have all of the following items at hand. The first thing that we'll need to do is to choose a map scale. The scale is the ratio of the distance on the map to the distance on the ground. For backyard homesteads, a scale of 1 inch to 10 feet is common. This means that an inch on your map represents 10 feet on the ground. Look at your engineer's scale and find the 10 scale. It will have the number 10 on the left-hand side of the ruler. You will notice that instead of the usual 1/16 of an inch, your engineer's scale is divided into 10 equal distances, represented by 10 small lines drawn into each inch of the 10 scale ruler. That means that you can easily measure the number of feet by counting each 1/10 of an inch as 1 foot. 1/2 an inch will be 5 feet. For larger sites, you may need to choose a 20 scale. Once you have your materials, begin to draw your map out to scale. For example, if your first property line measures 70 feet, and using the 10 scale, we know that each inch equals 10 feet. We would draw a line 7 inches long. If you have a small property, you may want to use another scale. Either 1 inch equals 5 feet, or even 1 inch equals 1 foot. Experiment to see which scale works best for your situation. Continue until all of your measurements are plotted onto your base map. Your site analysis begins with active observation of the features, elements, and processes occurring at your site. Active observation entails observing and interacting with the site. In your reading on the scale of permanence, you will learn about the different site elements that can be assessed, including water, microclimate, access and circulation, aesthetics, buildings, and infrastructure. We will begin our site analysis with water. First, let's review observations and interpretations and give you some examples. Remember, an observation is simply stating what exists. An interpretation offers some kind of explanation or judgment about what we see. Let's make some observations and interpretations about the photo in the slide. Observation 1. The grass is short. We don't know why the grass is short. We're just stating what we see without explaining it. Interpretation 1 is the grass has been mowed. We can guess the grass has been mowed, but we don't know for sure. Another interpretation, would be that the grass has been grazed by animals. Observation 2. People are gathered in small groups. Interpretation of this would be that people are perhaps having a class outdoors. Observations often have multiple interpretations that arise. As you begin your site analysis, try to stay in the observation stage as much as possible. Start making some observations at your site. Remember, stay with the observations and wait until you feel comfortable with observations before making any interpretations. Let's take a look at water at your site. Begin by taking a walk around your site to see where water is entering and leaving the site. Take some notes and draw out some sketches of what you see. Note where your downspouts and hose spigots are on your house. Now, back at your base map, place a fresh layer of tracing paper over your base map and label it Water Analysis. Begin drawing in and writing your observations. Which areas of your site are saturated after a rain event? Which areas seem to be dry? Which areas might be used to catch water? Try to observe the site during a rainstorm so that you can see the patterns of water as it makes its way across the site. Note all of these observations and interpretations on your water layer of your map. In a few days, go back and do a second water analysis, catching anything that you may have missed the first time around. Here's an example of a water analysis of a farm site. The blue lines show the movement of water through the landscape. Remember to show how water will travel off of buildings on the site. If you have a well or septic system, be sure to include it on the map. Also, you may want to note your observations and interpretations on the map as well. Take a look now at your local watershed. Try to find the major rivers, streams, lakes, ponds, and wetlands in your surrounding area. Often, these can offer clues to the overall picture that water plays in your landscape. How much water do you think you'll need at your site? Soon we'll be covering water management strategies, but water is one of the most important and sometimes most overlooked factors for a site. Gardens will use about 60 gallons per week per 100 square feet of garden space. That means that a bed that measures 4 feet by 25 feet needs at least 60 gallons a week of water. Another factor we might begin to consider is how much rain you could catch at your site. Some optional exercises would include calculating how much rain your roof could divert into rain barrels. These types of water catchment calculators can be found online. When you have lived at a site for at least a year, you can often go beyond the observation stage and look for patterns that you find related to how water behaves at your site. What processes can you uncover as you study water? At my site, I've noted the following pattern. The top of my driveway often has standing water after it rains for a few days. I can make an interpretation that the soil there is compacted and therefore doesn't allow for free drainage of water. This may be important to note if I'm making decisions about what types of plants to put in this area. Your analysis will be an ongoing process of observation, interpretation, and finding patterns.